Hello class, welcome to section 2.7 day 1. Today we're going to learn about derivatives and rate of change. So far you guys should already know what rate of change is, and that is slope. Okay, so we are going to learn about derivatives, which is a very large part of calculus. Okay. What is derivative? Derivative is the instantaneous rate of change at a point. When you think about this, we've already learned about instantaneous velocity. When we talked about instantaneous velocity, it was basically our average rate of change, our slope piece, and then we have to tack on the limit piece. That's what gives us the derivative. Okay, so definition of a derivative is given below. The derivative of a function f at a number a, denoted f prime of a, that's our notation, is what you see here below. Okay, if that limit exists, then you can calculate the derivative. So notation is that we got f of x, that is talking about your function or your original position, function. And then f prime of x is talking about the derivative of f of x. And derivative is rate of change, so it's your slope at one point, okay? Because it's in that instance. And just remember, if you have a slope at one point, a singular point, you're really finding the slope of a tangent line. So derivative is equal to the slope of the tangent line. That's how we can find slope at one point. So we could use this equation to find that slope. An equivalent way of stating the definition would be the one given below. However, you are finding the slope at a specific point. It's when x is equal to a and a is some number. Okay, so this only works if you're given a specific f of x value. But what you guys should notice is this looks very similar to just rate of change. Okay, we did f of b minus f of a, f of b minus f of a, all over b minus a. But now they're tacking on the limit to make it in that instant. Okay, so taking your slope and adding on that limit piece. So, quick little note. This function up here, this definition will always work. And we're basically today going to be dealing with this one, but this is day 1 of 3 on notes. So we will get to the other one, but this function up here will always work. And this one only works when you are given a specific x value. Only works if you have a specific x value. So let's go ahead and dive into it. So the good news is a lot of the algebra from today you've already encountered. Okay, so it says find the derivative f prime, that's usually how we read it, the derivative of f or f prime of the function. So here we're going to set up the definition. So the definition we had is limit as h approaches, just like we did on our last test with instantaneous velocity, h of 0 of f of a plus h minus f of a all over h. Okay. Since I am given f of x, I am actually going to write the definition using x's instead of a's. Okay, so you should be able to change this up. But if I am given the definition or the function with x's, I can actually also still do the limit as h approaches 0, f of, excuse me, x plus h minus f of x all over h. Okay, so these definitions mean the same thing, except for with this notation, I'm going to be using x's. And if I were to use this one, I would be using all a's. Okay, I know you guys like to use x's, so let's stick with using x's here, but they are equivalent. Okay, so in order to do this, I'm going to find f of x plus h. So I'm going to do a little side work to find that. Okay, I am going to clone this page if I can, because I'm going to run out of room. All right. So we're going to find, little side note, find f of x plus h, okay? In order to find this, wherever there is an x, I will now write x plus h. So I have 5 minus 2 x plus h to the third. Okay, and then in order to solve this, I gotta FOIL not once but twice, because I gotta write it 3 times. So what I'm going to do is just start with these two. We have multiplied x plus h times x plus h quite a few times. So if you FOIL it all the way out, you'd have x squared plus, you get xh plus hx, which is the same as xh. So plus 2xh plus h times h, which is h squared. And then we have to take that times x plus h. Now from here, I'm just going to keep writing on this, tacking on the 5 minus the 2. And I'm going to multiply this out. I would have x cubed, okay, plus, so I took this, now I'm doing plus x squared h, plus, now I have 2xh times x, so plus 2x squared h. And I'm going to take this one times this one, so now I got plus 2x h squared, plus, now I have to distribute my h squared to each part, so plus x h squared plus h squared times h is h cubed. Okay, we're getting close to almost being all the way done. I'm going to combine any like terms. So right now I got 5 minus 2, and then I have an x cubed, and I have no other x cubed, so that's good. Then I have x squared h here, and an x squared h here, so 1x squared h plus 2x squared h is 3x squared h. Now I have 2xh squared plus xh squared, which is, there's one of those, so I'd have 3 of those total, plus 3xh squared, and then plus our h cubed, at the end, h cubed. Okay. To continue simplifying, we're almost done. I need to go ahead and lastly distribute my -2 to each part here. Okay, so the 5 stays there, so I have 5 minus 2x cubed. Then I have minus 6x squared h minus 6xh squared, and then minus 2h cubed. Okay, and there it is, this piece all simplified. Okay, so I am going to write this down in this spot. And then the good news is we already know f of x. It's right here, so I don't have to do any extra work. Okay, so just retaking my slide from before, I will have equals my limit as h approaches 0. We just found this on the previous slide, so I'm going to rewrite this piece right here. We got 5 minus 2x cubed minus 6x squared h minus 6xh squared minus 2h cubed. That is that piece. Now I'm going to go ahead and subtract my f of x function, which is my function that I'm given here. So make sure you put it all in parentheses. So I have 5 minus 2x cubed all over h. Okay. Now we've done a lot of algebra already, but now the pattern should be the same when you guys have a polynomial. You should be able to distribute this negative. I'm going to write it above. So I'd really have -5 plus 2x cubed. And per usual, things should cancel nicely. And if they don't, you've made a mistake. Okay, so right now I would see my 5's cancel and my 2x cubes cancel. Then from here, if I wanted to calculate my limit, if I plug in 0, I still can't. But I notice I could factor out an h from what is remaining. So I'm going to factor out an h. So I have -6x squared minus 6xh minus 2h squared all over h. Now my h's will cancel. Once I cancel those out, now I'm totally fine plugging in 0 for h. Okay. Once I plug it in, remember you don't write limit anymore. So I'd have -6x squared minus 6x times 0 plus, or sorry, minus, it's a subtracting, subtract 2 times 0 squared. So this all cancels out, and I am left with -2x squared. And that is my final answer. This is the derivative function. Okay, and I can use this function to find the slope of my curve at any point. Okay, but this is my derivative function, which we're working on getting to here today. So another way you can write it is we found f prime of x is equal to negative 6x squared. That's the other way you could write it. Okay, so that is example 1. Example 2 is another polynomial. Okay, and we're going to use x, and it says find f prime of x. Okay, so writing down my derivative notation. So my derivative of x is equal to my limit as x approaches, gosh, not x, I wanted to do that today, as h approaches 0 of f of x plus h minus f of x all over h. And now I'm going to go ahead and find f of x plus h excuse me, as a little side note. Come back and fill it in. So I got to find f of x plus h equals, so wherever there's an x, and now here there's 2 of them, I'm going to write x plus h squared minus 8 times x plus h plus 9. So in order to handle x plus h squared, remember, we got to write it twice and FOIL it. And this one you guys are going to get really good with just saying what the final answer is, so you don't need to write this piece if you don't want to. But then I would have minus 8x minus 8h plus 9. And I'm going to FOIL this out here. If I FOIL it, I have x squared plus 2xh plus h squared. Then I got minus 8x minus 8h plus 9. And I just look if there's anything I can combine my like terms. Doesn't look like it, so should be good. Okay, now I'm going to go back and plug in what I got here. I just found this piece, so I'm going to write that down. So I'll have my limit as h approaches 0 of x squared plus 2x h plus h squared minus 8x minus 8h plus 9. Then we got minus the f of x function, which, good news, we already know what f of x is. It's right here. We got x squared minus 8x plus 9 all over h. Okay, so now I'm going to distribute my negative. So I have negative x squared plus 8x minus 9. Whoops, stop doing that. Okay, there we go. Minus 9. And then things once again should cancel. My x squareds cancel, my 8x's cancel, and my 9's cancel. If this second piece, you guys, doesn't cancel, it means you've missed a negative. It's your hint to yourself to go back and relook through your work. Okay, so make sure you do that. Then from here, I'm just going to write down what I have left. Got those 3 pieces, those 3 terms. So I have my limit as h approaches 0 of 2xh plus h squared minus 8h all over h. And now if I try and plug in 0 for h, I can't, so I need to factor out my h. So I would have 2x plus h minus 8 all over h. These h's cancel, and now I can plug in 0 for h. So I'd have 2x plus 0 minus 8, which leaves me with 2x minus 8. So that is my derivative. So I can label that as f prime of x. That's my one way of saying this is my derivative function, 2x minus 8. Okay. And that is example 2. So example 1 and 2 are polynomials, and they should be solved very similarly. Example 3 is your rational function. So this one's a little bit different. So we're going to have common denominators. Going to have to get common denominators and all that fun stuff. Okay, so let's just write down our limit for our derivative. It's saying find the derivative of f prime of x. We want it to have an x in it. So we got our limit as h approaches 0 of f of x plus h minus f of x all over h. Okay. So with this one, there's not a ton of side work that you can do, but we could write a little note if we want to, since it's not a polynomial, to find f of x plus h. So wherever there is a t in this case, I'm now going to write x plus h. So I have 5 x plus h minus 4 all over x plus h and then plus 2. Okay, so I'm just going to rewrite the top up here. This is really 5x plus 5h minus 4. Okay, now I'm going to plug it in. We will have our limit as h approaches 0 of f of x plus h. So we got that 5x plus 5h minus 4 all over x plus h plus 2. And I don't need to rewrite the parentheses on this piece because there's no distributing that needs to happen. And then minus f of x. Notice this is f of t, so I need to write it with x's instead of t's. So I'd have 5x minus 4 all over x plus 2 all over h. So now if I were to try and plug in 0 for h, I can't because I would have 0 in my denominator. So what I have is multiple fractions, so I need to make them be 1. So I'm going to get a common denominator. This first fraction has a denominator of x plus h plus 2, and this one doesn't. So I'm going to multiply the top and the bottom over here times x plus h plus 2. Okay, and then to make this look the same, I have to multiply the first one times x plus 2. Okay, now my denominators are common, so I'm going to put my numerators together. In order to do that, I need to go ahead and do a lot of distributing. Okay, so on my next step, we're going to just be doing some distributing. So we have our limit as h approaches 0, and you're going to need to write small. I'm going to try and do my best here. So we will have 5x times x. We got 5x squared, and then plus 10x. Then I'm going to distribute my 5h. So plus 5xh or hx, whichever way you want to write it, and then plus 10h. Then we have to distribute the negative 4. So minus 4x minus 8. That is that first numerator all FOILed out. Then minus, and I'm going to put all of this in parentheses again. This is where it kind of gets hard. I know it's going to be a long string, so I'm actually going to rewrite it below here. Okay, so we'd have 5x squared plus 5xh plus 10x. Then I distribute my negative 4, so I got minus 4x minus 4h minus 8. That is all of this numerator. Then I got to put that over my common denominator, which is x plus h plus 2 times x plus 2. And all of that then is over h. All right, now, as usual, I'm going to take and distribute my negative to my numerator, or in the numerator to this piece. So if I distribute this negative, I'm going to write a plus sign here. It'll make this negative, this negative, this negative. Now this will be positive, positive, positive. Okay, let's take a look. Do things cancel? My 5x squareds would cancel. My positive 5hx is the same as 5xh, or my negative, so those will cancel. My negative 10x and my positive 10x will cancel. I got a negative 4x and a negative 8. And I think that is all that will cancel. Okay, so what do I have left? I got a 10h and a 14h. Okay, so we're going to write that down. My limit as h approaches 0. We got 10h over my common denominator all over h. Now I have this fraction really over h over 1. So in order to get it out just to be one fraction, I'm going to multiply it by the reciprocal of the denominator, so 1 over h. This all simplifies to 1. These h's will cancel. Oh, I hope somebody caught me. I said it. 10h and 4h really should not be 10. This should be 14. My bad. So I have 14h there because of those two. Those h's will cancel. And then if I continue, I have limit as h approaches 0, 14 over x plus h plus 2 and x plus 2. Can I now plug in 0 for h? Yes, I can. It won't cause me to have 0 in my denominator. If I do, I have x plus 0 plus 2, which just gives me x plus 2. So this equals my, not my limit, this equals, plugging it in, so I'm not writing limit, 14 over x plus 2 times x plus 2. It's okay to write it that way, but usually if you have x plus 2 times x plus 2, you're going to write it as x plus 2 squared. And this would be my derivative function for my rational. Okay. So that is example 3. So to recap on that one, what we did is we got a common denominator, did a lot of distributing, okay, multiplying out, and then we did a lot of canceling. Okay. After that, we multiplied by the reciprocal of the denominator piece to get those h's to cancel. And then from there, you were good to plug in your h approaches 0 value. All right, the last one, we have a square root. Finding the derivative of f prime of x. So definition of derivative will be f of x plus 8. Oh, sorry. Got to start out the right way. Limit f prime of x equals our limit as h approaches 0, f of x plus h minus f of x all over h. Okay. So I'm going to go ahead and find f of x plus h. Once again, not a lot of simplifying because it's not a polynomial. So our little note, I'm going to do it up here so it's out of my way. F of x plus h equals the square root of 7 x plus h minus 1. If I distribute my 7, I have 7x plus 7h minus 1. And now I'm going to go ahead and plug it in. So I have my limit as h approaches 0, and f of x plus h is what I have written here. So I have the square root of 7x plus 7h minus 1. Then minus f of x. This is f of t, so once again, just rewrite it, but instead of using t's, we're going to use x's. So we have 7x minus 1 all over h. So at this moment, I try and plug in 0 for h, because that's what the limit's telling me to do, and it doesn't work out. I see I have radicals. Okay, when we have radicals, in order to handle them, I multiply by the conjugate. Okay, so the conjugate of this guy is exactly the same, except for the sign in between my radicals changes, so it's plus. We're going to multiply the top and the bottom. And now I'm going to go ahead and multiply it out. So we will have the square root of 7x plus 7h minus 1 times the exact same square root. The radicals cancel, and I'm just left with what is underneath. Then when I take this radical times this one, that is the positive version of these two things being multiplied together. And then we follow it up with taking this radical times this one. However, it's the negative version. So those two things will cancel each other out. We don't need to write that piece. Okay, then we go ahead and we're going to take this radical times this one. It's a negative times a positive, so it's going to be a negative. And then the square root of 7x minus 1 times the square root of 7x minus 1. I am just left with 7x minus 1. All over my denominator. Remember, do not FOIL out that piece or multiply it out. You only multiply out the conjugate. So we got 7x plus 7h minus 1 plus square root of 7x minus 1. Now my numerator, if I distribute out my negative, I would have negative 7x plus 1. And I should see that things will cancel. My 7x's will cancel and my 1's will cancel. So what I am left with is my limit as h approaches 0. I got 7h up top. then I got h, and then I got my square roots, 7x plus 7h minus 1 plus square root of 7x minus 1. I try and plug in 0 for h here. However, 0 times whatever this is would leave my denominator be 0, which we can't have. But then I notice the h's will cancel. And now that I've done that, can I plug in 0 for h? Yes, I can. So I'm plugging it in, so I'm not going to rewrite limit. So I'll have 7 in the top. 7x plus 0 minus 1 will just be the square root of 7x minus 1 plus square root of 7x minus 1. And then if I have the square root of 7x minus 1 plus the square root of 7x minus 1 again, how many square roots of 7x minus 1s do I have? I have 2. So I can write it like this. Okay. This is a sufficient answer. If you wanted to rationalize, you can. In calculus, you usually don't. So if you wanted to stop here, you can. But if you're like, I've had to rationalize so far in math, I want to rationalize this. I'm going to rationalize it on the next page. So right now our derivative is equal to 7 over 2, and then what's it, the square root of 7x minus 1. Good. So we wanted to rationalize, we take the top and the bottom times 7x minus 1. So on the top, I would have 7 square root of 7x minus 1. Then I would have 2 times, when I multiply those two together, I would be left with just what's underneath my radical. And then I would probably distribute my 2. So I'd have 7 square root of 7x minus 1 all over 14x minus 2. This is a good answer. Totally fine leaving your answer like this unrationalized if you wanted. But that is the end of the notes. Your homework is listed here. It's a little out of order, but you had 4 examples and you have 4 homework problems. So this number 25 is like your example number 2. Number 26 is in like example 1. The only difference is instead of having x to the third, you have x to the fourth, so you need to write it out, whatever it is, 4 times. And FOIL, what I recommend is FOIL these 2 things and FOIL these 2 things and then multiply them out. But it's a lot of multiplying. Then example, or problem number 27 is like example 3. And then lastly, 30 is like example 4 on your notes. Okay, if you have questions, let me know. Otherwise, have a good day and I'll talk to you later.